Well, good afternoon, everyone, and welcome to another Rhino Toolhouse virtual demonstration brought to you by the Rhino Toolhouse Group. Just want to welcome you guys here. We're going to take a couple seconds, let people in, and just get adjusted. So just hold tight for 10 seconds, and we'll get started. All right, so let's get going here. So good afternoon, everyone. My name is Matt Jordahl. I'm the sales engineer up in Maple Grove, Minnesota. And joining me today is our applications engineer, Dylan Smith. We're really excited to be presenting you guys a really cool partnered solution today. The last 7 weeks, we've had a lot of fun just putting together different demos, and we hope it's been educational for you guys. Hope that you guys have been learning a lot. We definitely had a good time just putting these together. And so if you've been able to participate in those, we just want to say thanks. Most of those have been posted on our YouTube page. So if you want to go back and take a look at some of the past events we've done, just type in Rhino Toolhouse to the YouTube page, and I would definitely encourage you to check that out. And so, yeah, I mean, one admin thing, with any questions that you guys have throughout today's presentation, the bottom of your screen, there's a little chat function. And we'd encourage you guys to be thinking about different questions that you have throughout the presentation and then just inputting them there. We'll have a moderator that will be going through them, and then myself and Dylan will address those towards the end of the presentation. So I know there's a lot of people that know who we are, and there's some new faces as well. But a little bit about the Rhino Toolhouse. Our mission with our company is to provide and identify the most innovative industrial solutions to ultimately help our customers succeed. And so I think today's presentation, you're really gonna see a very innovative solution that can really be beneficial for you guys. Before I get started, I wanna just go through a quick story. I'm gonna take you back to 2007 for this story. This is when I first got a cell phone. My first cell phone was the Motorola Razr. At the time, it was one of the most popular cell phones on the market. It was a sleek looking device that you could text, you could call, you could take sub-quality photos. And at the time, it was one of the coolest things out there. Later that year, the iPhone came out, and it completely revolutionized the mobile phone industry. And so smartphones over the past 13 years really took off, and really the reason for this is just because of the benefits and the value that it brought to customers. I mean, you could plug in GPS coordinates, you could access the internet, all these things that you couldn't do with a regular phone, you could now do with a smartphone. And so in 2020, you don't really see many people using flip phones anymore. It's the majority of the market is smartphones. So now if we take a look at robotics and manufacturing, so robotics have been around since the 50s, but really it wasn't until the 80s until industrial robots became more of a thing. And so what an industrial robot is, it's a robot that requires hard guarding and safety measures around the robot and provides automation to a manufacturing floor. Well, in the mid-2000s, 2005 to be exact, collaborative robots were introduced to the market. And so now there was industrial robots and there was collaborative robots. And over the past 15 years, especially in the 2010, that decade, there's been a growth in collaborative robots. And so this is just, this is what they project from 2014 all the way up to 2025. They project collaborative robots are really gonna see a surge in growth in the manufacturing environment. And really what today's presentation is going to be all about is just educating you guys on 5 key benefits to why collaborative robots are becoming so sought after today in manufacturing, because they're adding a lot of value and they're helping manufacturers succeed in the workplace. And so our partnered vendor today is Doosan. If you're not familiar with who Doosan is, maybe you're a huge baseball fan like myself, and maybe you saw the Twins Yankee series, or maybe you saw other playoff baseball teams last year. I know I saw my Twins get crushed by the Yankees last year, which was a huge bummer. But I did notice that the whole playoffs was sponsored by Doosan. And so Doosan is a large company that they have many different divisions, including collaborative robots. And so now I'm going to turn it over to Dylan Smith. He's going to talk a little bit more about Doosan, and then also get into the 5 key benefits about collaborative robots.
Thanks, Matt. So I want to first start off by saying, welcome guys, and give you a little bit more background on who Doosan is as a company. So Doosan has been around since before the 1900s. And last year, their global revenue was over 200 billion. They are a global Fortune 500 company. They have over 42,000 employees worldwide, so they're pretty serious. They have a wide variety of specialties, including industrial machinery, like the Doosan collaborative robot, but they also do a lot of other stuff as like component materials, heavy industry, energy. Like recently, they've been doing a lot of advances with hydrogen battery cells and a lot of consumer services. Now, into the collaborative robot. What is a collaborative robot or Cobot? That is a robot intended to interact with the human in a shared space or to work safely in close proximity. Cobots stand in contrast to traditional industrial robots, which are designed to work autonomously with safety assured by isolation. So, more traditional robots take up a wide footprint. Now, more about the Doosan Cobot specifically, it was released back in 2014 with the 4 different models. The Doosan M series robot, which I got here. This is our largest or longest model, but the capacities for payload are 6 kilograms, 10 kilograms, and then 15 kilograms, or all 33 pounds. And we have our arm reaches from 900 millimeters, 1300 millimeters, 1700 millimeters, which this one is the longest unit. And that's about 5.5 feet. So when thinking about cobots, we'd like to point out the 5 key benefits of automation and why you're all here today. Now, 1, the increased productivity. The lifespan of a Doosan with 0 maintenance is 36,000 hours, which also translates to consist of over 4 years of straight 24-hour-a-day production. Number 2, cobots are a lot more flexible. They take up less space and minimal changes to actually make any changes to your workpiece and the production layout to add or improve an existing process. The collaborative model was designed to be easy to program and lightweight. Doosan has a high dexterity, allowing them to automate many different tasks. When you think of robots and automation, all kinds of applications might come to mind. We have threaded insert here today, but there's many applications like assembly, fastening, pick and place, packaging and palletizing, inspection, or even fluid dispensing. Possibilities are only limited by really your creativity. Number 3, increased repeatability. A robot performing a task is going to allow for a much more consistent product and increasing quality. With a repeatability of plus or minus 0.1 millimeter, your robot performing the exact same task every time and increasing your quality. Number 4, and in my opinion, the largest advantage is the safe automated solution. So a collaborative model is designed to be safe just in how they are. Just a little bit, I'll show you exactly how accurate the force sensors are and why they're needed in this Doosan Cobot, and workers are protected by this collision detection. You can work along this M series without any safety fencing and share tasks between the human and the Cobot exactly like I will do today. And lastly, number 5, the accelerated ROI. Not only do collaborative robots have a much lower setup and investment costs compared to their industrial counterparts, but by automating the mundane and common tasks in your facility, you are now freed up that your operators and workers pursue more advanced skills and specializations. This also leads to really an increase in job satisfaction, as you'll see in this demonstration I have. Now let's talk about the key features of Doosan and why they kind of stand out. And really, I'm going to start off with my favorite, the direct teach unit. It's a nice, convenient solution compared with their teach pendant. So, more traditionally, you're familiar with the teach pendant, so this is actually how you do a lot of the programming. But Doosan specifically thought they could improve that even more by adding what I like to call the cockpit or direct teach unit right on top. So this is a series of 5 buttons that actually allow me to do a lot of programming directly with the robot itself and actually free up both hands to kind of do what I want. The first button, kind of the biggest, is kind of the float button. You can move the robot however you want, turn it every axis. Just by holding down that one button, it moves and you can place it exactly where we want to go. Next, we got these 2 programmable buttons. They have a few different features, but the default ones and kind of most popular, I'll show you right now. This first button, if I hold that down, and I can actually move the robot in just the Z axis in relation to the tool. So you can see it goes forwards and backwards, and if I actually try to go side to side in the X and Y axis, it kind of springs back to exactly where I need to go. And lastly, this other programmable button allows me to stay just in the X and Y plane. It doesn't go up and down in the Z axis at all. And this really just ensures that you can program a lot faster and place the robot exactly where you need to go. So really good for deployment and redeployment. And then there's just those other last 2 buttons that do a lot of confirming and entering when you're actually doing your programming. They allow you to put in a lot of different waypoints and tasks when you go throughout your process. Now, kind of dive into really the second biggest key feature is the Doosan torque sensors. It's a 6-axis robot, so that means it can turn around 6 different joints, but inside each one of these joints is a torque sensor. That's really important in controlling in the safety and controlling the different force. So with a touch sensitivity of 0.2 newtons, this robot is easy to program, but can be a great solution for polishing, deburring, and grinding, and many other consistent tasks using this force on a work surface. Doosan Collaborative Robot also offers the advantage of being able to work in what we call industrial mode. So we can break up the Doosan workspace into actually 4 different work areas, and depending on where a worker may be, or me in this case, maybe we can switch up what the robot's actually doing and go from collaborative to industrial mode and back. So like, for example, let's say a worker's preparing a part, putting O-rings and stuff, then he actually hands it off to a robot for inspection. When you do this handoff, you might want to go into that collaborative mode to make sure the operator's a lot safe and you have a lot lower speeds. But now the robot grabs that part, goes to do its own thing. You might switch over to industrial mode, so you have a lot higher, decrease your takt times and improve your efficiency. So it's a nice key feature, being able to break up into those 4 different planes and then switch those to collaborative mode, industrial mode. But you can interface in Doosan with many different ways. Inside of the controller, there are 16 inputs and outputs. So we have a controller down here, it's kind of the brains or computer of the operation. There's 16 discrete inputs and outputs just for easy wiring. And that's also how our desuder tool is being controlled today. The end of the arm also has 6 inputs and 6 outputs. So that's right at this wrist joint. You can see right here. So that's nice and convenient for a variety of reasons. The solution is a great way to interface with simple I/O and end effectors, or even allow you to design your own end effector without excessive wiring going back down the arm. Just a nice clean setup. In addition, there are also 2 analog I/O ports to work with for variable electronics. Good example, like think of your thermostat at home. That uses a variable voltage to actually give you that input. In regard to protocols, Doosan can interface with Modbus, Profibus, EIP, and TCP/IP. So really kind of your standard industrial protocols. And in terms of end effectors, we use a variety, and there's a big combination, but the possibilities are endless. We often use Robotique, Schunk, Schmalz, or Zimmer, but I encourage you to go on Doosan's website and check out their different videos and even look at some of the proven end effectors. But now let's dive into our demo here we have today. So I'm kind of going to do 2 different slightly related demos. The first one is going to be this torque tool. I have a desuder transducerized DC torque tool that's going to put in some threaded inserts for me. And the second one is a nice quick demo showing you exactly why we need those 6 safety sensors to keep the operator and myself safe. So the first demo is putting these little threaded inserts into a plastic piece. This is actually a proof of concept we did for a local customer up here, where one operator all day was just putting in these inserts. So it's very time consuming and is not allowing him to do a more complicated task. So the customer came to us and asked, how can you improve this for me? And they really had 2 kind of key achievements in mind. First, I want to decrease my takt time. I want to go faster, throw out more parts out there. Business is good. Second, I also want better quality. First of all, when you have these threaded inserts, if you drive them too far, you completely ruin this piece and have to throw it away. Or if it's not in there far enough, you have a poor finish and you might not be able to assemble your final part when all said and done. So that's why we have this desuder transducerized tool to actually measure the angle we're turning these, so we get a nice flush threaded insert every single time. And secondly, the robot's just automating this entire task, freeing up the operator to do something a lot more fun, in my opinion, and being able to add value somewhere else, a lot more advanced. So I'll dive into that right now. So I can hit play, it goes home, then I'll immediately come out and ask for the threaded insert. Ideally, we have some sort of blow feeder or bowl presenter actually giving this thread insert, but just for today's demo, I'm going to be doing that by hand. So I can take this, push it up on the robot, it'll screw itself right in. Ideally here, we'd have some sort of input signal from that bowl feeder saying, hey, I just saw a proc sensor switch off that we got a part there and can continue. So I will hit continue here. It actually brings back to our work surface. It'll insert this thread and actually thread cut into the plastic, and then it'll reverse itself back out. So you see we have a nice flush surface every single time. I'll grab a couple more and continue that process to just kind of show you how that's performing. And that's definitely another key reason why we needed the desuder transducerized tool, is because we're actually backing out of this threaded insert. So you can imagine once these plastic pieces are machined out and cut to size, they're immediately thrown down the table and the robot can easily add these all in. Makes a nice, faster solution. I'll dive into our second demonstration to show you why the safety of these are key and why we actually need the full 6 torque sensors as opposed to some other brands might have your full 6, causing some safety issues. So let's say I'm doing the exact same operation, but maybe I start talking to my coworker. I'm not quite paying attention, start to lean down right on here. And the robot's slowly coming down right towards my hand. But you can actually see here with those torque sensors, it saw that actually has my hand and is not gonna, turn the tool on, the tool's fully deactivated, and also it's not gonna keep pushing down on me. So I can actually lift up if I wanted to, or even put my finger under there and it's perfectly safe. So that's why we have the 6 key sensors for applications exactly like that for safety, but also really good for those different applications where I need a consistent force. But I want all of you to leave here today to think about how utilizing Doosan to automate your process can first increase your productivity. Second, add a flexible option to your automation facility. Number 3, increased repeatability. 4, how it's safe, like I just showed. And 5, accelerate the ROI. This could really be a machine tending, assembly and fastening, or thread cutting as we have here today. A pick and place is very common. Packaging and palletizing are very common tasks that we can easily automate. There's inspection or even fluid dispensing. But thank you. I'll give it back to Matt.
Yeah, thanks, Dylan. You did a great job. Yeah, like Dylan mentioned, today's demo is really just one specific application. When we're looking at a fastening application, we're taking a torque tool and we're running down different fasteners into a workpiece. But like Dylan mentioned, there's plenty of other applications that just this Cobot can be used for. And so, yeah, Dylan kind of highlighted some of the other ones, but pick and place, inspection, gluing and bonding. Really, the applications are endless. We've even seen people use this to refill coffee in their offices if they wanted to. I mean, you can really play around and do a lot of cool things with this. So, yeah, with that, I think we'll just open it up to question and answers.
Yeah, we have a few here. What is the max reach and payload?
Yeah, so you can actually see the example we have here shows the max reach. That's about 5.5 feet. The max payload is about 33 pounds.
Perfect. What are some of the most common applications?
It's definitely, when you first deploy an automation process to a brand new facility without any sort of automation, you want to kind of take those easy wins. That's your very common tasks are easily repeatable. That's maybe like your pick and place. Nice, easy, there's an easy ROI there because now you freed up this operator to actually add value somewhere else. And it's nice and fast application. So there's your just pick and place. Assembly is a huge one. And then inspection are pretty common as well.
What are the most common end effectors used?
Yeah, definitely. So we can do a lot of custom things, but we like to use a lot of robotique, schmalls, or shunk. In this case, you actually saw I 3D printed my own kind of end effector to sandwich clamp a Doosan or a Doosan tool. So there's a lot of variety there, and you can actually create your own if needed.
Awesome. Who are some of the customers that are currently using Doosan Robotics?
Yeah, there's quite a few people already using Doosan robots, but some of the bigger ones maybe be Toyota and Bobcat, just bigger brand names.
Can you explain the differences and the benefits of Doosan versus universal robots?
Yeah, there's definitely a few there, but I think the key ones would be our direct teaching unit, allowing the end customer, you guys, to program this a lot faster and easier. The software is a lot more intuitive for ease of programming. Next, there's the 6 torque sensors inside of here, allowing a lot more safety aspects there. There's probably a cost difference of us being a little bit more cost effective as well. But you might want to talk to your Rhino Tools rep and they can go over it with you a lot further.
Awesome. All right, question from Joe. What is the amount of force required to make the robot stop movement? I.e., if it hits a person, how much force will it hit with before stopping?
It's a highly variable function. I mean, you can, depending on how close you are to an operator or your exact needs, you can make it really variable. So, you breathe on it the wrong way, it might stop. Otherwise, if you want to have a little bit more rigidness to it, you can increase that. So it's kind of up to you. Or we can follow the ISO standards.
And follow up to that question, he says, I saw you had your hand under the tool to demonstrate safety. Can you allow the robot to contact you as it's moving from point A to B to demonstrate its stopping?
Yep, exactly. And that would be part of our collision detection that we could set up depending on how hard you want to hit the robot to make it stop. That's definitely an easy feature. Using those same 6 torque sensors, it can do that.
Perfect. And then what would you use to switch between industrial and collaborative modes, a floor scanner or pad on the floor?
Mm-hmm. It really depends on your exact operation, but we often like to use just laser scanners. Those seem to work the best, and they're very easy to redeploy if we were moving our station or things like that. They just take up a very small footprint.
So what is the minimum force you can set to make the robot stop on collision?
I mean, the minimum force is, I mean, has accuracy up to 0.2 newtons, and you can get it down to about like 1 Newton if you want to stop it just with barely touching it at all.
Is there any way to demonstrate that? Instead of having your hand under, is there a demo that you have now that you can demonstrate that stopping force?
I mean, I can definitely start the same demonstration we're doing and just hit it.
Yeah, so if it's doing an operation and you stick your hand, say, on the arm, it would basically just stop with little to minimum force.
So right now I didn't tweak that too much just because it wasn't key to the demo, but I'll start this, and when it comes over, I'll simply hit it and it stops right there. So I can see it turns red and gives me an error message saying we came in contact with a zone. But does that kind of answer the question?
Yes, it did. Thank you. We'll give it a couple more seconds here if anyone has any other questions. Yep, got one. Can I set collaborative mode and non-collaborative mode to speed up production in not working areas?
Yes, exactly. So like we said earlier, you can easily set this into kind of 4 key planes, or use some sort of scanner to tell the robot to slow down. So either have fixed points where I want the robot to speed up and slow down, or use a scanner to actually tell it to switch between the different points.
Next one, have you interfaced the robot with measurement devices to check thickness with a direct input, not an analog translation, and what protocols are supported?
Can you read that one more time?
Yep, have you interfaced the robot with measurement devices to check thickness with a direct input, not an analog translation, and what protocols are supported?
Okay, so I'm guessing you'd probably use a Cognix camera or Keyence camera, some sort of machine vision or a laser scanner, but you could probably just use Modbus. It'd be a pretty good industrial protocol for that type of thing.
Okay, next one, do I have to have a scanner?
You do not, as we do not have one here at all.
All right. Is there a specified reaction time for collisions? Kind of a follow-up. You may be able to set it very low on impact, but for say if it hits someone on the head, it would be more impactful if it doesn't react immediately. I.e. 1 newton meter of force to the head versus 1 newton meter to the chest. I mean, those would be very different.
Yes.
So you could set that reaction time for collision.
I mean, once it sees so much force, it'll stop. So I guess it doesn't want to see any sort of time. There's no real time base. It's more based off seeing excessive force. So once you go over this threshold, it's not like it happens for 3 seconds or 5 seconds. If it happens at all, then we stop. Just to really be a true collaborative robot and be safe. You might want to contact your Rhino toolhouse engineer and get a little bit more clarification on what you're asking.
Yeah, and if you have a particular application that you have in mind, Joe, we can certainly get you more information on that. Thank you, Mike. So if we'll give it a few more seconds here if there's any other follow-up questions. Well, I think that kind of covers it. one comment from Tony. I think the answer might be best answered in joules of energy at max Cobot speed.
I couldn't quite hear that.
It was just a comment. I think the answer might be best answered in joules of energy at max Cobot speed. Is that correct?
In terms of force required to stop the robot?
Yeah.
Or, I don't know, I think force would be the best there for a collision, not necessarily joules in terms of energy that the robot's, experience or using.
Okay.
Yeah.
That might be a more in-depth question to contact your local rep to ask.
Yeah. All right. Well, take it away, guys. I think that is it. Great job. Thank you very much.
Yeah, thanks again, everyone, for your time. Hopefully this was helpful and hope you guys learned something from today. Just want to give you guys a quick reminder, tomorrow at 1 p.m. Central Time, so 2 p.m. Eastern, we'll be doing Fastening 101. Dave Johnson and Skip Young will be doing that. So that's a great opportunity to learn about fastening. Yeah, with that, thanks again, everyone, and have a great rest of the Monday.